So let's look at multiplying three binomials, okay? Now, a binomial is just a polynomial with two terms in it, hence the bi word, okay? So a binomial looks like this, so we'll do a nice and easy one. So let's have x plus 1, okay? That is a binomial. Now, we're going to multiply three of them together. Now, you're usually used to multiplying two binomials, which is often called multiplying double brackets, okay? And so this is sometimes called multiplying triple brackets. But you're multiplying out binomials, okay? So one thing I'm going to do straight away is to show you a little trick just in case you forget. Sometimes you'll see it like that, okay? Now that needs to be expanded out so you know exactly what it is, okay? It's that, okay? It most definitely isn't x cubed plus 1. Where you've got x cubed plus 1 cubed, okay? You've got to write them out 3 times and you're going to multiply them together, all right? Now, there's a nice easy way to do this. First thing we do, take these two, okay? And we're going to multiply them out. So this one's going to stay here like that. And then we're just going to multiply these two out first, and you already know how to do that. So let's start. So the first term of the first binomial multiplies all of the second bracket, and then the second term of the first binomial multiplies the second bracket as well. Okay, so if you're stuck, I don't know what is going on there, that's gone there, and that's gone there. Okay, so x plus 1, we haven't done that one yet, so we'll do this. X squared plus x is the first set of multiplications, plus x plus 1. Collect them all together, and we've got x squared plus 2x plus 1. Okay, so nice and easy that bit. And now what we're going to do is multiply the binomial by the quadratic, which is now what we've got. Okay, now there are two ways to do this. We can do it the way we've just done it, okay? So let's have a go at that to start with, just so you can see what we're doing. So we'll stick it up there. So we could say, okay, so here's the first term of the first bracket, x, and that's going to multiply the quadratic. And then the second term of the first bracket, the plus 1, is also going to multiply the quadratic, and then multiply them out. X cubed plus 2x squared plus x squared plus 2x plus 1. Okay, always be careful about this and this, because if that was negative, it would flip the signs in the bracket as you're multiplying out. Okay, so just be careful. I like to throw that in sometimes just to mess around with your head. Then we collect all the terms together, starting with the highest power. There's only one cube term, so that goes there. Okay, and then that's done. There are two squared terms, plus 2x squared, plus x squared is plus 3x squared. There are two x terms, plus x plus 2x is plus 3x, leaving the constant, which is the plus 1, and that is the answer. Okay, now that's one way to do this. The other way to do it is to use the grid method. Now, we often frown on the grid method, but when you start to multiply large polynomials, so quadratics and moving upwards, the grid method offers one or two advantages here, primarily in terms of layout and making sure you multiply the right things. So if I was going to do this in the grid method, I would first of all say, well, I have two terms, okay, in the x plus 1, so I'm going to put that in there, and I'm multiplying, and I have three terms in the quadratic. I have, where's it gone? Oops, it's there actually. X squared, I have the plus 2x, and I have the plus 1. So that is going to give me 6 multiplications. So that's good straight away, because I know I'm going to do 6. Whereas if you do the other method, and especially if you use that abhorrent FOIL method, it's often very easy, as it becomes more complicated, to miss certain multiplications. So there we go. X times x squared, x cubed, plus 2x squared, plus 1x, okay? And then x squared there, plus 2x, plus 1. Okay, so there's our 6 multiplications. which we can see match the 6 multiplications we've got down here. Okay. Now, one of the advantages of this is that it lines up the terms diagonally. So it's very easy to see if you've made a mistake. So what I mean by that is there's only ever one cubed term, okay? One of the highest power. So that means here's our x cubed. But notice diagonally, there are the squared terms. So it's very easy to find them and to know that you haven't made a mistake. So for instance, if I put plus 2x and didn't put a squared there, it's an easy check for me to see, well, actually, diagonally, it should be a squared. Okay, there's those diagonally, plus 3x. And there's only ever one of the smallest term, okay, plus 1. All right, now, there's a lot of advantages to this, but just imagine if we were multiplying 4 terms, so you ended up with a quadratic times a quadratic. So if that was now x plus 1 to the 4, we'd have x squared plus 2x plus 1, and we'd have x squared plus 2x plus 1. So now we know we've got 3 by 3, we know we're going to have 9. The grid method lovingly lays it out and lines them all up like that. So it's nice and easy, okay? So don't poo-poo it. You don't have to use it, but it can be useful. Now, there are some little tricks you can do if you pay attention to what's going on that save you having to do the full method, okay? And here's an example of one of them. So this looks like there's just 2 binomials, but as you notice there's a square there, you are now super smart and know that that is actually 3 binomials, because that's what it means, okay? X minus 1 times x plus 3 times x plus 3. Now, you could start by just going, right, let's multiply x plus 3 by x plus 3, but if you're thinking about this, always give something a look before you get into the main process. And this, hopefully, should ring a bell, okay? Because that is the form called the difference of 2 squares, okay? It's an identity. If you remember it, the identity is a squared minus b squared. That's the difference of 2 squares equals a minus b, a plus b. So without having to multiply anything out, we can actually just replace one with the other, okay? Which would be nice and easy. So if you can see, this thing here looks like that, okay? We use the 3 equals there because it's an identity. So if that equals that, we can write what's on the left-hand side. So we can straight away write here x squared minus 3 squared times x plus 3. So that becomes x squared minus 9. That's x plus 3. And then it's a simple 2 bracket multiplication. So x squared, x plus 3, minus 9, x plus 3. Okay, so x cubed plus 3x squared minus 9x minus 27. And that's the answer. Okay, so sometimes look out for that. They use difference of 2 squares quite a lot, okay? Sometimes they try and hide it, especially if it's a higher question, but it's always worth looking for, okay? Now, if they really want to mess with your brains, okay, they can bring in another type of question. So, consider this. Have a go at it, see what you get, and see whether you can work out how to do it, okay? But let's consider this. X plus 2, x minus k, and x plus 4. Okay, now we know if we multiply that out, so we're going to say it's identical to, what is it identical to? I've written this down somewhere. X cubed plus 3x squared minus 10x minus 24. Okay, and the question is, what value of k? Now, there is an easy way to do this, which I'm going to show at the end, okay? Because I want to show you the full method first. So, the first thing we're going to do is we are going to multiply out that monstrosity on the left-hand side, okay? So, you're not going to enjoy this. Now, I would rewrite this way to start with. I'd stick the nasty thing with the 2 variables there, or the constant, the variable, I should say, and I'd put these here. So, because it's a product, it's commutative, so you can move the bits around, so that doesn't matter. Okay, and I'm not going to write blah, blah, blah on that side, so I'm not going to write that out again. So I'll work these bits out. So x minus k. Now, I'm not going to do the full thing because I'm going to do it quickly. So x squared plus 2x plus 4x is plus 6x plus 8. Okay, and then I'm going to use the grid method. Okay, so I'm going to go x squared plus 6x plus 8. And I'm going to go x, and I'm going to put a minus k there. I'm going to do that. Okay, and I'm going to multiply this all out. So, this is where the grid method makes this really nice and easy. Okay, x squared times x is x cubed, plus 6x squared plus 8x. Now the fun starts. Okay, minus k times x squared is minus kx squared, plus 6x times minus k is minus 6kx, and plus 8 times minus k is minus 8k. Now the tricky bit is adding this stuff up. Okay, so what we're going to try and do is, if you go back up here, there's my highlighter, this is a highlighter. Okay, look at this, and you look at this. Now, to match a coefficient, you need to make both sides look the same. Now, by that, what I mean is, on the right-hand side, we have an x cubed, an x squared, an x, and a constant. So what we're going to do is we need to have that same structure on the left-hand side. Okay, so here we go. So we have an x cubed, that's fine. Okay, now here's where we can use our diagonals, okay, which is why this is so nice. So we have plus 6x squared minus kx squared. So that gives us plus. Now, we know we have to have an x squared there, and we need a coefficient in here, okay? So we've got plus 6, and we're taking away k. So that is 6 take away k goes in there, because basically we factorized out the x squared. Next thing we do, same thing with this other one. So this is going to be an x term. So we're going to have an x term here. Okay. And we're going to have a coefficient here. Now we'll put a plus here. So we need to see what goes in here. So we've got minus 6k x plus 8x. So that's minus 6k. Or we could write it as 8 minus 6k. Okay, and then the last thing we've got is, I'll do that, is the minus 8k. Okay, and this equals, or is identical to, x cubed plus 3x squared minus 10x minus 24. Now, to make this work properly, we need to make sure all the signs are around the right way. Okay, so we have x cubed here, we have a plus there. So 6 minus k x squared. Okay, so we'll stick that there. We have an x cubed there, which is positive, and we do have a plus there, and we'll stick the 3 there. Okay, and we'll put our x squared there. So this is a positive 8 minus 6k x. Now here we've got a negative 10x, so to make sure it is exactly right, we're going to flip the sign, and we're going to stick a negative 10 in there. Okay, and then the last one is a negative 8k. Now they are the same, so we could keep them that way, but just for the sake of completion, we'll put plus minus 8k, and we'll put plus negative 24. Okay, so now we've got x cubed, x squared, x, and a constant, x cubed, x squared, x, and a constant, and they're all being added together. Okay. Now we can do what's called matching coefficients. Okay, so we can take the coefficient, which is the term or the number usually in front of a power of x, if that's what we're using, and match it with its pair on the other side. So, for instance, if we look at x squared, so there's an x squared, there's an x squared, they're both positive. Now if these are identical, that means that the coefficients have to be identical. So what we could write is 6... Oh, not with that pen we couldn't. Who did that? Where's my nice pen? There it is. So both those x squareds match the coefficients. So the coefficient in this one is 6 minus k, and the one on the other side is 3. And then we could find out what k is. So if that's the case, k has to equal 3. So that we've worked out from matching the x squared coefficients. We could do it with the x coefficient. Okay, so on the left-hand side, we have 8 minus 6k. And on the right-hand side, we have a negative 10. Okay, so if that's the case, how do we get to negative 10? So negative 10, 18 equals 6k, so k equals 3. Okay, nice and sensible. And then the constant itself, now, if we want to be really posh, we know that was the x squared, that's x to the power 1, and this is actually the x to the 0 term. But x to the 0 is 1, which is why we get a constant. Okay, so we have minus 8k. Actually, I've made a mistake there. Hang on, let me rub this out. Up here, where I've got plus minus 8k, the bracket should actually go round that, okay? Because there's no x term that we've written. So there, we've got minus 8k equals negative 24. I keep saying minus. Okay, and we can see from that 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 means k is 3. So all three of them prove to us that k is 3. We only needed to do one of them. In more complex maths, especially at A level, you'll use this technique a lot more, okay? You'll usually end up using simultaneous equations with it as well. Okay, so that's how we find out k is 3, but that's the very long method. The easier method relies on something we did before, okay? Now, if you remember, we said that when we multiply out using the grid method, we can see there is only ever one x cubed term, the highest term, and there's only ever one constant term, if you remember that in your little grid. Okay, so knowing that, we know that x times x times x has to be x cubed. But we also know for the constant that plus 2 times minus k times plus 4 has to equal negative 24. Okay, so we could have actually skipped straight away and forgot all the stuff and gone down to that one. Okay, now it only works for the highest term, the cubed, and the lowest term, the constant, because all the other terms are composite terms. They're created by adding products together, which you can see by the diagonals in the grid method. Okay, and that's how you multiply 3 binomials.